Hello guys. So today we'll see the next question in our LeetCode 75 series, and let's go to the screen. Let me take you to the screen. Yeah. So what does the question says? Our question is basically container with most water. And the question is you are given an integer array heights of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height I. Basically, we are given heights, like array of heights, and find two lines that together with x-axis form a container such that the container contains the most water. Okay. So to contain the most water, it should require volume, but according to the question, we will find the area that will find the largest rectangle such that it will have more area, like largest rectangle in sense of area, and that will return the how that will be the most water container that will find and will return that area. And for the rectangle area, we know we will require length and breadth only, cause area of rectangle is length into breadth. And for length, if we see that if we taking the horizontal as a length and vertical as a breadth, then like height and length, we'll take height and length into height, length into height will be our area here, and length will we can find from index subtraction, and height we have given, like whichever will be the less less height, like that will take, cause if we can say like in first example we can see that this one has 8 height and the last one has 7 height, so we took the 7 height, cause if we take the 8 height, then water will be overflow, right? It will be overflown from this height which is 7, so we can't take both as 8, we can take both as 7, and the length will be this index minus this index into minimum height, so that will be area for this, and we need to return the maximum area only. So yeah, the approach is pretty much simple, that will have two pointers. Let me write. We'll have two pointers, L and R, and L will be 0 first and R will be at last, like at the last index, like height dot size minus 1. Let's take height dot size is n and it will be n minus 1 cause it starts from 0. And what we will do, first their length as L and R will subtract it, R minus L, and that will be our length, and we require height, and height will be the minimum height, like between two, which is the minimum, that will our height, and height into length will be the area that we require, and we'll store the max one, like we'll store the area is equals to length into height, and if it is greater than the previous area, then we'll store that as a result, and whichever the height is less, like if length like height at the L is less, then we'll increment the L, and if height at the right will be less, then we will decrement the R. That's how we'll do it, and let's see how we can code it. Or we want to dry run it, then we can do, but I don't think you will require it. That you understood, right? Through the code you will understand that what I was trying to say. If you didn't understood it through the code, you will definitely understand it. That's, yeah. Let's take n as our height dot size, and we'll have L pointer and our R pointer, and L will be 0, and we'll initialize the L as 0, that will starting from left, and our right pointer will be at right, that n minus 1, and we'll check until our length is less than R. Then there will be no point, right? When length and r at the one point, then the length will be 0, the L is equals to r, then the length will be 0, r minus L will be 0, so we won't take that. And if r crosses the L, then the length will be negative, and we don't want that. We just want if r and L until this, and if like this, then we don't want it. Until we, if they are equal, then also we don't want it, because anything into 0 will be 0 only, because L minus r we are going to take, and if L is equal to r, then it will be, length will be 0, and we won't take that. So that's why I written L is less than r. Till then we'll run that loop. Our height will be, to require the basically here we want max area, so let's first store max area. Max area is equals to 0 only. I'm not taking negative because our height won't be negative here, because they have given that height will start from 0 until 10 raised to 4, and our n will be from 2 to 10 raised to 5, that we will have minimum two heights. And yeah, so that's how we'll do it. Heights will be 10 raised to 4, maximum will be 10 raised to 4 into 10 raised to 5, it will be 10 raised to 9. So it will also can be stored in int. So I am taking int max area is equals to 0. I'm starting it with 0. And height, for height will take the minimum of heights, heights at L, and heights at it's heights, right? Okay, height, it is height. Just height at L and height at R, and that will be our height. Okay, let me take it h only, cause vector name is height and we can't override it. Like if you override it, then it will throw error, so we won't take height is equals to minimum height L and R. We'll take h is equals to minimum of height L and height R. Then we'll have length between them. So let's take it as breadth or width. Let's take as width. Width is, if there is no such as minimum or maximum, width is basically difference between two indexes, that is r minus L. So to verify this, I'm just doing this. If we have n is equals to 2, like n is equals to 2, then my L will be 0 and my r will be n minus 1, that is 1, and the width will be, for this will be r minus L, which is 1 minus 0, which is 1, and that's what I have required, that between 2 and 1, that 1 and 0 I will require that only. I was just taking to make sure that we are calculating the correct width. So yeah, we are calculating the correct width, r minus L will be the width, and int area, like our area will be height cross width, and max area is equals to max of max area and area. And if my height at L, here in this step we'll store the maximum area, and now we'll check which pointer we need to update, like L pointer or right pointer, like left pointer or right pointer. For that we'll check if height at left is less than height at R, then just increment it. Like we just took the area of that height and area, like into width between them. Now we took the height and width. Now I want more height, and obviously the width will gonna decrease. But if I got more height, then width area gonna, I will get more area. Like I will get the coordinates which, like using which I can get more area, and that can be our answer. So my greedy here I'm thinking greedily, that now I took the width and height, and if I can increase the height, then I can increase the area. So if my length at height at L is less, then I will increase it. Like I will increase not the height, I will increase the left pointer, so that I am finding the more height code, like more height, so that I can get more area. Now you like think I explained it well, and you will also understand it that what I was trying to say. I'm just thinking greedily that I want more height, so I'm finding it. And to take the most more width, I am started it from L is equals to 0 and R is equals to n minus 1. And accordingly, according to the height, I'm updating the left pointer and I'm right pointer. So yeah, through this process, like till we complete the while loop, we will get the answer. Like it will store in the max area, and will return the max area. You can also check it by doing it yourself, like dry run, and yeah, we'll check it is accepted. Now we'll submit it, and we'll check. Yeah, it beats 100%. And how much a time complexity for this algorithm we took. Yeah, this our algorithm, like our code take just big of n time complexity as here. This while loop will be for L and R. What if the R is much great? R is the max. R is equals to like height at n minus 1, that the last height is the max height, and every time will be L is getting reducing. L or R, whatever it will be. It will be for every index it will run. So the answer will be big of n, for like this loop will run for the big of n. And for minimum and maximum, we are just checking that which one is less, and it is just two parameters are there. So in big of one time it will return. So yeah, and the calculation, it will take big of one time only. For minimum, it will take big of one. For this comparison also, it will take big of one. So overall time complexity will be big of n, cause all this will big of 1 will run for the big of n time, and time complexity will be big of n, and n will be the, what will be the n? N is the height dot size, that is our length of like length of the array. It is the n. What is the space complexity here? The space complexity will be constant because we are not storing it anywhere, that given height, vector height, and we just took the this called like this variables which takes the constant size. And for the answer also we require just int variable, so it is the constant. And the space complexity will be big of n, sorry, big of 1, that is the constant time complexity constant space complexity we are taking. Yeah, that's it guys. So bye.